Hello students, welcome back to the maths class. In today's class, let us solve few more problems on the concept of scalar product or the dot product of two vectors. Let's see the first question. Find the projection of the vector A, which is equal to 2i cap plus 3j cap plus 2k cap on the vector B, so which is given by I cap plus 2j cap plus k cap. So we have already seen what is projection of vector A on vector B. They are mentioned. We need to find the projection of the vector A on the vector B. So projection of vector A on vector B is equal to vector A dot vector B whole divided by, we need to write the magnitude of which vector? On what vector they have asked to find the projection, we need to write. So here they have asked for on B. So this will be magnitude of vector B. Okay, so this is equal to vector A, which is given by 2i cap plus 3j cap plus 2k cap dot. Next you have vector B, I cap plus 2j cap plus k cap whole divided by magnitude of vector B root of. So here this is your vector B. For only vector B you need to find the magnitude. So that will be equal to 1 square plus 2 square plus 1 square. Therefore this is equal to. Now let us find the dot product between the vectors, vector A and vector B. So first 2 into 1, it is 2, then plus into plus, plus 3 into 2, 6, then plus into plus, plus 2 into 1, it is 2, divided by root of. So here it is 1 plus 4 plus 1. Okay, so this will be equal to 10 divided by root 6. So this is the projection of vector A on vector B. Let us take up the next question. So here also we need to find the projection of the vector I cap minus j cap on the vector I cap plus j cap. So in order to find the projection vector, here let us take up the first vector as vector A, that is I cap minus j cap, and the second vector I'll call it as vector B, which is I cap plus j cap. So they have asked us to find the projection of vector. This we have called it as vector A. Vector A on this vector, which we have called it as vector B. So here also projection of vector A on vector B is equal to vector A dot vector B by magnitude of vector B. So this will be equal to vector A is given by I cap minus j cap dot vector B is given by I cap plus j cap whole divided by root of only the magnitude of vector B. So here it is 1 square plus 1 square. So when I find the dot product, now here 1 into 1 it is 1, then minus into plus minus 1 into 1 it is 1 divided by root 2. So in the numerator you have 1 minus 1 which is 0. 0 by anything, again it is value is 0. So the projection here is equal to 0. Next you have this similar problem. So you have find projection. Again we need to find the projection of this vector. So let us call the first vector as vector A, which is equal to I cap plus 3j cap plus 7k cap. And the second vector, we call it as vector B, which is equal to 7i cap minus j cap plus 8k cap. Okay, so here again you need to find projection of vector A on vector B. So same formula you are going to apply and you are going to simplify. This is your homework problem. Okay, I just give you the answer for this. When you solve the problem, you can verify the answer. For this, the answer is 60 divided by root 114. Okay, I leave this problem for your homework. You can verify the answer. The verify your answer, you will get the projection of vector A on vector B, you will get it as 60 divided by root 114. Next problem. Evaluate the product of 3 into vector A minus 5 into vector B dot, means dot product between this and the other vector is 2 into vector A plus 7 into vector B. So let us consider the given two vectors dot 2 into vector A plus 7 into vector B. Therefore, this will be equal to, see here, now this, the first one, this with this, you need to find the dot product. So 3 into 2, it is 6. Then you have vector A dot vector A. Okay, next, the same thing now with the second vector. Means the second term in the second vector. So 3, so first let us multiply the sign here, plus into plus, it is plus, then 3 into 7, 21, then the dot product between the vectors, vector A and vector B. Next, coming to the second term here, so minus into plus, it is minus, 5 into 2, it is 10, then we have vector B dot vector A. Next, the final one, minus into plus, it is minus, 7 into 5, it is 35. Then you have vector B dot vector B. Therefore, this is equal to 6 into, what is vector A dot vector A? Do you remember the observation? Okay, in the observation I have told you vector A dot vector A is equal to magnitude of vector A the whole square. So we are going to use that observation. So vector A dot vector A is magnitude of vector A the whole square. According to the observation, so vector A dot vector A, we know this is equal to magnitude of vector A the whole square. Next, plus 21 into vector A dot vector B. So minus 10. Vector B dot vector A can also be written as vector A dot vector B, as the dot product between the two vectors is commutative. So you can easily write vector A dot vector B can also be written as vector B dot vector A. Same way, vector B dot vector A can also be written as vector A dot vector B, because dot product holds commutative property. Okay, so this can also be written as vector A dot vector B. Then you have minus 35. So vector B dot vector B, the same as vector A dot vector A. So vector A dot vector A can be written as magnitude of vector A the whole square. In the same way, vector B dot vector B can also be written as magnitude of vector B the whole square. So this is equal to 6 times magnitude of vector A the whole square plus 21 A dot B, vector A dot vector B, minus 10 vector A dot vector B. It is nothing but plus 11 vector A dot vector B. Then minus 35 magnitude of vector B the whole square. This is the product for the given vector. Now moving on to the next problem. Here they have told if vector A is a unit vector. The first clue given, vector A is what kind of vector? It is a unit vector. When they have given that any vector is a unit vector, it is understood that the magnitude of that vector is equal to what? It is equal to 1. Therefore, first the data given, vector magnitude of vector A is equal to 1. And they've given this, the dot product between vector x minus vector A dot vector x plus vector A is equal to A. This is the next thing. What we need to do? We need to find what is the magnitude of vector x. So let us consider the given dot product. It is given as vector x minus vector A dot vector x plus vector A is equal to A. So as we simplified in the previous problem, the same way we are going to do. So here x, vector x dot vector x first. vector x dot vector x, then plus into plus it is plus, then you have vector x dot vector a, vector x dot vector a. Next this becomes minus into plus, it is minus, then you have vector a dot vector x, vector a dot vector x. Next it is minus into plus, it is minus, then you have vector a dot vector a. This is equal to what? This is equal to 8. Now, what is vector x dot vector x? Again, using the observation. So, vector x dot vector x is magnitude of vector x the whole square plus vector x dot vector a. As we know, the dot product is commutative. I can write vector a dot vector x can also be written as vector x dot vector a minus. So, vector a dot vector a can be written as vector a the whole magnitude of vector a the whole square, which is equal to 8. So, this and this get cancelled. So, you have magnitude of vector x the whole square minus magnitude of vector a the whole square, which is equal to 8. We already know what is the value of magnitude of vector a, which is what? Which is given as 1. How? Because they have mentioned the vector a is a unit vector. So let us substitute. So magnitude of vector x the whole square minus this value is 1. For magnitude of vector a is 1 whole square is equal to 8. So magnitude of vector x square this becomes 1. Therefore this becomes 8 plus 1. Magnitude of vector x square is equal to 9. Therefore magnitude of vector x is equal to 3. Okay, understood? So the next problem here, find the magnitude of vector x. Same thing. If for a unit vector, again they have given for what kind of a vector? For a unit vector a. So again vector a is a unit vector, hence the magnitude of vector a is equal to 1. So again they have given the same procedure you should follow for this problem also. So let us solve together. I hope even you people are making note of it. So let us solve together. So this will be equal to vector x dot vector x. Then what do we have? Plus vector x dot vector a. Then it is minus vector a dot vector x minus vector a dot vector a is equal to 12. Okay, so this can be written as magnitude of vector x the whole square plus magnitude of vector x dot vector a minus, as this is dot product is commutative, so we can write it as magnitude of vector x dot vector x dot vector a minus magnitude of vector a the whole square, which is equal to 12. So these two get cancelled. So you have magnitude of vector x the whole square minus magnitude of vector a the whole square, which is equal to 12. Substituting magnitude of vector a as 1. So 1 square again is equal to 1. So magnitude of x square minus 1 is equal to 12. So magnitude of x square vector x whole square is equal to 12 plus 1 13. So magnitude of vector x will be equal to what? Root 13. Okay, here we are speaking about the magnitude. The magnitude will be always positive. I hope you have understood this problem. Next problem. Find magnitude of vector A and magnitude of vector B if vector A plus vector B dot vector A minus vector B is equal to 8, and also they have given a clue that magnitude of vector A is 8 times magnitude of vector B. So let us consider for the solution, let us consider vector A plus vector B dot vector A minus vector B, which is equal to 8. Now let us find the product of this. So this will be equal to vector A dot vector A, then plus into minus it is minus, vector A dot vector B, then plus into plus it is plus, vector B dot vector A, and it is minus vector B dot vector B, which is equal to 8. So vector A dot vector A can be written as magnitude of vector A the whole square. So here it is minus of vector A dot B. Vector B dot A can also be written as vector A dot B because dot product is commutative. Then magnitude of vector B the whole square, which is equal to 8. So this get cancelled. So you have magnitude of vector A the whole square minus magnitude of vector B the whole square is equal to 8. Now I am going to use the data which is given in the question. They are given that magnitude of vector A is 8 times magnitude of vector B. So instead of A, magnitude of vector A, I am going to substitute it as 8 times magnitude of vector B. So here magnitude of vector A can be written as 8 times magnitude of vector B the whole square minus magnitude of vector B the whole square, which is equal to 8. So this, if I simplify, this will be 64 times magnitude of vector B the whole square minus magnitude of vector B the whole square, which is equal to 8. So here this is 64 magnitude of vector B the whole square minus 1 magnitude of vector B the whole square. So 64 minus 1, it is 63 magnitude of vector B the whole square, which is equal to 8. So what will be the magnitude of vector B the whole square, which is 8 divided by 63. So simplifying, hence magnitude of vector B will be equal to root of 8 divided by 63, where root 8 can be written as 2 root 2 and root 63 can be written as 3 root 7. Okay, now, so we found what is the value of magnitude of vector B. So we have found this. We need to yet find what is magnitude of vector A. So by considering the given data, given that what they are given, magnitude of vector A is 8 times magnitude of vector B. Now by substituting the value of magnitude of vector B, we can find the value of magnitude of vector A. So let us substitute. So 8 times magnitude of vector B is given by 2 root 2 divided by 3 root 7, which is now equal to 16. 8 into 16 root 2 divided by 3 root 7. So the magnitude of vector B is given by 2 root 2 by 3 root 7 and magnitude of vector A is given by 16 root 2 divided by 3 root 7. Moving on to the next problem. So the next problem, finding. We need to find magnitude of vector A minus B, vector B, if two vectors A and B are such that then magnitude of vector A is equal to 2, magnitude of vector B is equal to 3, then vector A dot vector B is equal to 4. For this, I am going to consider, consider magnitude of vector A minus vector B the whole square. So this can be written as vector A minus vector B dot vector A minus vector B. This I've written because we know that vector A dot vector A is equal to magnitude of vector A the whole square. So magnitude of vector A minus vector B whole square can be written as vector A minus vector B dot vector A minus vector B. So here we need to find the product between these two. So this will be vector A dot vector A, then it will be minus vector A dot vector B, then it is minus vector B dot vector A, then minus into minus plus vector B dot vector B. So further simplifying this, therefore magnitude of vector A minus vector B the whole square is equal to, this is magnitude of vector A whole square minus vector A dot vector B, then minus vector A dot vector B. Again I am repeating, this is because of commutative property plus magnitude of vector b the whole square. Let's get cancelled. So you have magnitude of vector a whole square plus magnitude of vector b whole square. They have also given the values for magnitude of vector a. The value for magnitude of vector a is 2. Therefore, this becomes 2 square, which is 4. Plus magnitude of vector b, they have given it as 3. Here we have magnitude of vector b the whole square. Therefore, 3 square it is 9. So 9 plus 4, it is 13. This is magnitude of vector A minus vector B the whole square. But we need what? Only the magnitude of vector A minus vector B. So magnitude of vector A minus vector B will be given as root 13. Okay. Next problem. Show that each of the given vector is a unit vector. This is your first question. Friends, we need to prove they have given 3 vectors. We need to prove all the 3 vectors separately as a unit vector. How we tell a given vector is a unit vector? That is, when we get the magnitude of that vector as 1, then we can say that the given vector is a unit vector. So let us find the magnitude for each of these vectors and see if we get a magnitude as 1, then definitely it is a unit vector. So let us consider the first vector as vector A, which is equal to 1 by 7 into 2I cap plus 3j cap plus 6k cap. Okay. Now I am going to multiply this 2 by 7I cap plus 3 by 7j cap plus 6 by 7k cap. So when we multiply, let us find the magnitude of this. So magnitude of vector A is equal to root of, what you should do? 2 by 7 the whole square plus 3 by 7 the whole square plus 6 by 7 the whole square. 2 by 7 whole square plus 3 by 7 whole square plus 6 by 7 whole square. So simplifying this you will get it as 4 by 49 plus 9 by 49 plus 36 by 49. So what is the LCM here? The LCM is 49. So you get it as LCM 49. So in the numerator it is 4 plus 9 plus 36. What is 4 plus 9 plus 36? It is 49 again. So you get root 49 by root 49. What is root 49 by root 49? It is 1. So we got the magnitude of the vector A as 1. So I can say the vector here, first vector I have taken. So the first vector is a unit vector. Now the assignment for you is you need to check whether the remaining 2 vectors are unit vector or not by again simplifying in the same way. You can easily just see here just the scalar components have got interchange, that's all. Everywhere 2, 3, 6 is there. So when you square again you will get a same value. Definitely it is a unit vector. This was our first question. Okay. In this question, this was the first part. The second part, they have asked us to show that they are mutually perpendicular vectors. So, if you remember again the observation, when I say the 2 vectors are perpendicular, what does that imply? It has implied that the dot product between the 2 vectors should be equal to what? Should be equal to 0. So, let us prove that. I am going to erase this. I know everyone can easily find the magnitude of all the vectors. So, I hope you have copied this. So, in order to prove that they are mutually perpendicular, okay, to each other, what I do is I first consider the first vector and the second vector. So here it is considered vector A. So I directly multiply this 2 by 7 into I cap plus 3 by 7 into j cap plus 6 by 7 into k cap. This is my first vector. The second vector, I call it as vector B. Again, this vector here. So again, I am going to multiply this 1 by 7 inside. So it is 3 by 7 into I cap minus 6 by 7 into j cap plus 2 by 7 into k cap. I need to find whether these 2 vectors are mutually perpendicular or not. So in order to find that, what we need to do? We need to find the dot product between the vectors. If the dot product, if we get it as 0, then we can conclude these two are perpendicular. So let us find the dot product between the vector A and vector B. So vector A, which is 2 by 7 into I cap plus 3 by 7 into j cap plus 6 by 7 into k cap dot. Then you have 3 by 7 into I cap minus 6 by 7 into j cap plus 2 by 7 into k cap. So finding the dot product, you all know how to find the dot product. So what we should do? We should multiply 2 by 7 with 3 by 7. So when I multiply 2 by 7 with 3 by 7, it is 2 into 3, 6 divided by 49. I cap dot I cap becomes 1. So we usually don't write. Next, plus into minus, minus. Next, you should multiply 3 by 7 into 6 by 7, which will be 18 by 49. Next, plus into plus, plus 6 by 7 into 2 by 7, that is 12 by 49. Okay, so what is the LCM here? Again, the LCM is 49 here. So if we simplify, 6 minus 8 plus 12. What is 6 minus 8? 6 minus 8, 6 minus 18 it is. 6 minus 18, it is minus 12. So minus 12 plus 12 is 0. So 0 by 49 is equal to 0. So we got the dot product between the vector A and vector B as 0. So I can conclude that these two vectors are perpendicular. But they have asked us to show they are mutually perpendicular. So what you should do next is, you should consider vector B dot vector C. Find the dot product between vector B dot vector B and vector C. Again, you should prove it is equal to 0. After that, then you should take vector C dot vector A. There also, those two will be mutually perpendicular. You will get the result as 0. This two things, you should do it as an assignment. Okay? Next problem. Here, they have given two vectors, vector A and vector B. We need to show that vector A plus vector B and vector A minus vector B, this is vector A minus vector B, are perpendicular. Okay, so here, in order to prove that, so we need to find the dot product between which two vectors? We need to find the dot product between the vector A plus vector B and vector A minus vector B. So let us first find what is vector A plus vector B. So vector A plus vector B is equal to, vector A is given as 5i cap minus j cap minus 3k cap plus vector B I cap plus 3j cap minus 5k cap. So this is equal to 5i cap plus 1i cap 6i cap minus j cap plus 3j cap, it is plus 2j cap minus 3k cap minus 5k cap, this is minus 8k cap. Okay, next let us find what is vector A minus vector B. So again it is 5i cap minus j cap minus 3k cap minus I cap plus 3j cap minus 5k cap. Therefore this is equal to, now 5i cap minus 1i cap, which is 4i cap. Then you have minus j cap. This becomes plus, minus into plus, it is minus. So minus j minus 3j cap, therefore minus 4j cap. Then it is minus 3k cap plus 5k cap, which is plus 2k cap. Now we need to find that the dot product between these two is, means we need to find the dot product and we need to prove it is equal to 0 so that we can tell that these two are perpendicular. So vector A plus vector B dot vector A minus vector B we need to find. So vector A plus vector B is given by 6i cap plus 2j cap minus 8k cap dot vector B, which is 4i cap minus 4j cap plus 2k cap. So let us find the dot product. 6 into 4, that is 24. Then plus 2 into minus 4, that is minus 8. Minus 8 into plus 2, that is minus 16. So minus 16 minus 8 is 24. So 24 minus 24, which is equal to 0. So we have proved that the vectors, vector A plus vector B dot vector A minus vector B is equal to 0. Hence these two vectors are perpendicular. As I keep repeating that when you are finding and for perpendicular, you should prove that the two vectors, the dot product between the two vectors as 0. Okay. Moving on to the next problem. Again here, they've asked us to show that this vector is perpendicular to the other vector for any two non-zero vectors A and vector B. As we have discussed, when any of the vector is 0, definitely the dot product between them is 0. So they have mentioned that these two vectors are actually not zero vectors. They are non-zero vectors. So let us take up. So we need to find the dot product between this vector and that one. So first vector is magnitude of vector A into vector B plus magnitude of vector B into vector A dot. Then next we have magnitude of vector A into vector B minus magnitude of vector E into vector K. So we need to find the dot product between these two vectors. Let us see whether we get it as 0 or not. So finding the product. So this with this one I am going to multiply. So magnitude of vector A dot magnitude of vector A. Then we have vector B dot vector B. So when I find the product, this with this one, you get magnitude of vector A, magnitude of vector A, then vector B dot vector B. Then this with the second term of the second vector. So that will be minus vector A, magnitude of vector A, magnitude of vector B, then we have vector B dot vector A. Next, this one, so this will be plus magnitude of vector B, magnitude of vector A, then we have vector A dot vector B. And the final minus into, sorry, plus into minus, it is minus. Then we have magnitude of vector B into magnitude of vector B into vector A dot vector A. So simplifying, therefore this is equal to magnitude of vector A into magnitude of vector A is magnitude of vector A the whole square. We know that vector B dot vector B will be equal to magnitude of vector B the whole square. Then minus, this is magnitude of vector A, magnitude of vector B. This, see, vector B dot vector A can be written as vector A dot vector B because of commutative property, plus magnitude of vector B, magnitude of vector A into vector A dot vector B, then minus magnitude of vector B the whole square, magnitude of vector A the whole square. So if you see, this get cancelled. And here also, there you have magnitude of vector A whole square, magnitude of vector B square, then here it is plus magnitude of vector A square, then magnitude of vector B square, there you have minus magnitude of vector B square into magnitude of vector A square. When this get cancelled, so we got as 0. So I can say that the dot product between the vector this and that one is 0. Hence I can conclude that these two vectors are perpendicular to each other. Next problem. They have given three vectors, vector A, vector B and vector B. And they are telling that if three vectors are such that vector A plus lambda times vector B is perpendicular to vector C. So they have already given this vector is perpendicular to vector C. What does this imply? This implies that the dot product between vector A plus lambda times vector B and vector C is equal to 0. They have given that it is perpendicular. Therefore, from this I can say that the dot product between vector A plus lambda times vector B dot vector C is equal to 0. This is the given data. That is, vector A plus lambda times vector B is perpendicular to vector C. So from that, we can draw the conclusion that the dot product between these two vectors is 0. This is the given data. What we need to find? We need to find the value of lambda. So in order to find the value of lambda, let us first simplify this. So in order to simplify this, what I am doing is, and we have already seen in the observation that the dot product is distributive over addition. I am going to apply the same thing. Therefore, this is vector A dot vector C plus lambda times vector B dot vector C, which is equal to 0. Therefore, lambda times vector B dot vector C is equal to minus of vector A dot vector C. Therefore, lambda is equal to minus of vector A dot vector C whole divided by vector B dot vector C. Don't cancel this C and C. Okay. Next. So we need to find what is the dot product between vector A and vector C and also vector B and vector C. So lambda is equal to minus of. So what is vector A we want first? So vector A is given by 2i cap plus 2j cap plus 3k cap dot. Then we have vector C. So vector C is 3i cap plus j cap whole divided by. Next we have vector B dot vector C. So vector B dot vector C, vector B is given by minus I cap plus 2j cap plus k cap dot vector C. Vector C is 3I cap plus j cap. Therefore, this is equal to minus of 2 into 3, it is 6 for I dot I. Next it is 2 into 1, it is plus 2. Next we have 3. Whether do we have k component here? No. If there is no k component, what should we understand it as? It is 0. So 3 into 0 will be equal to 0 here. Whole divided by. Next, minus 1 into 3, it is minus 3. Then you have plus 2 into 1, it is plus 2. Then 1, again you don't have k component here, therefore it is understood it is 0. So, or else you can even write this as plus 0 k cap if you want. Or else just 3i cap plus j cap. So, 1 into 0, it is 0 plus 0. Okay, so simplifying, this is equal to minus of 6 plus 2, it is 8, whole divided by minus 3 plus 2, it is minus 1. So the value of lambda is equal to 8. Next problem. So before starting the next problem, the last problem which we have discussed is also important, and the problems which we are going to discuss is also important. So make an important note in your book. So here, if vector A, vector B and vector C are unique vectors such that vector A plus vector B plus vector C is equal to 0, find the value of vector A dot vector B plus vector B dot vector C plus vector C dot vector A. So the first data which is given is the vectors vector A, vector B and vector C are what kind of a vector? They are unique vectors. When they are given unit vector, what can you conclude? You can conclude that magnitude of all these vectors is equal to 1. So first you should write in the solution, that is, given that magnitude of vector A is equal to 1 and also magnitude of vector B is equal to 1 and given magnitude of vector C is equal to 1. This is the first data. Then they have given that magnitude of vector A plus vector B plus vector C is equal to 0. Sorry, not magnitude. It is just vector A plus vector B plus vector C is equal to 0 vector diagonal. So when they have given that vector A plus vector B plus vector C is 0 vector, what will be the magnitude of a 0 vector? The magnitude of a zero vector will be definitely equal to what? 0. So from this implies that the magnitude of vector A plus vector B plus vector B will be equal to magnitude of a zero vector, which is equal to 0. This is zero vector, this is 0. So in order to find this value, I will be considering, okay, consider magnitude of vector A plus vector B plus vector C the whole square. So using the observation, this can be written as vector A plus vector B plus vector C dot vector A plus vector B plus vector C. Again, I am reminding you, this is because of this observation. Okay, so this, when you find the dot product between these two vectors, you get it as magnitude of vector A whole square plus magnitude of vector B whole square plus magnitude of vector C whole square plus 2 times vector A dot vector B plus 2 times vector B dot vector C plus 2 times vector C dot vector A. If you remember this directly, it is fine. You need not find the product of each term with each term. So you just remember this. So this is equal to. Now, let us start substituting the values. So first thing, here you have magnitude of vector A plus vector B plus vector C the whole square. So what is the magnitude of vector A plus vector B plus vector C? It is 0. What is 0 square? Definitely it is equal to 0. Next, magnitude of vector A. We already know what is magnitude of vector A. Magnitude of vector A is 1. So this is 1 square, it is 1. Plus, what we have next? We have magnitude of vector B. We know that magnitude of vector B is again 1. So it is 1 square, it is 1 again. Similarly for C. Plus, so from these three, here we need to find only the dot product between vector A plus vector B plus vector B plus vector C and plus vector C plus, vector C dot vector A. So what I do is I take common, 2 common from these 3. So taking 2 common, I get vector A dot vector B plus vector B dot vector C plus vector C dot vector A. So this is 0 is equal to this. When I add up these terms, this is 3 plus 2 times vector A dot vector B plus vector B dot vector C plus vector C dot vector A. So we need to find the value of this one. So I shall write here. So minus 3 is equal to 2 times vector A dot vector B plus vector B dot vector C plus vector C dot vector A. Therefore, minus 3 by 2 will be equal to vector A dot vector B plus vector B dot vector C plus vector C dot vector A. So we now found the value of this. Understood? This is a very easy problem. See, when you remember all the observations, definitions and the concepts, you can easily solve just by applying it. So here first they have given unit vector, so it is understood that magnitude is 1. We have applied the unit vector definition. Next they have given that the sum of these 3 vectors is a 0 vector. So their magnitude, when you have a 0 vector, the magnitude of a 0 vector, we know it is 0. So that I have done. Then we have considered magnitude of vector A plus vector B plus vector C the whole square. We have applied one of the observation. We have simplified. After simplifying, if we just substitute the values given in the problem, we can easily find the required value. Now moving on to the next question of the similar type. So here you have, they have given that 3 vectors, vector A, vector B and vector C satisfies the condition. They have given that again the sum of these 3 vectors is a 0 vector. So from this what we can understand, that is when sum of these 3 vectors is 0 vectors, this definitely implies that the magnitude of these sum of these 3 vectors will be 0. Next, evaluate the quantity. Again, we need to find this value. But here, The magnitude of vector A is 1, magnitude of vector B is 4, and magnitude of vector C is 2. Again, we are going to apply the same formula. Only difference is here. There they have given unit vector, so all the magnitude it was 1, but here they have specified. So let us solve it together. So consider magnitude of vector A plus vector B plus vector C the whole square. So this can be written as what? So this can be written as vector A plus vector B plus vector C dot vector A plus vector B plus vector C. So this is nothing but magnitude of vector A whole square plus magnitude of vector B square plus magnitude of vector C square plus 2 times. You can even directly take 2 common or even write it as vector A dot vector B plus 2 times vector B dot vector C plus 2 times vector C dot vector A. So we know that this value is 0. So next magnitude of vector A is given as what? So 1 square is 1. Next magnitude of vector B is given as 4. We need magnitude of vector B the whole square. So 4 square it is 60 plus magnitude of vector C is given as 2. We need magnitude of vector C square. So it is 4 plus here from this what you can take common? 2 times vector A dot vector B plus vector B dot vector C plus vector C dot vector A. Therefore, this is equal to 21, 16 plus 4 plus 1, 21 plus 2 times vector A. So here, now, they have given that this A dot B plus B dot C plus C dot A is equal to mu. So I just replace this by mu. So this will be minus 21 is equal to 2 mu. We need to find the value of mu. Therefore, mu is equal to minus 21 by 2. These two problems are important problems. We can ask for 3 marks. Okay, even the previous problem which we have solved, that is your 23rd problem, even that is an important problem. Next problem, let vector A, vector B and vector C be 3 vectors such that magnitude of vector A is equal to 3, magnitude of vector B is equal to 4, magnitude of vector C is equal to 5. And each one of them being perpendicular to the sum of the other two. Find what is magnitude of vector A plus vector B plus vector C. The condition or the clue which is given is each one of them is being perpendicular to the sum of the other two. So here they are given 3 vectors. So each one of them is, let me consider any of the one vector out of the 3 vectors. So I will consider vector A. Each one of them is being perpendicular to sum of the other two. So sum of the other two means you should take the remaining 2 vectors sum. And they are telling that each one of them is being perpendicular to the sum of the other. Means this is perpendicular to this. Therefore, the dot product between these two is equal to 0. Okay. So this implies that. So from this I can write vector A dot vector B plus vector A dot vector C is equal to 0. Let me call this as equation number 1. Have used scalar property, means sorry, not scalar property, distributive property here. Next, okay. Similarly, we can write vector B dot vector C plus vector A. When this is equal to 0, again each one, now I have taken the vector B, is perpendicular to the sum of the other two. The remaining 2 are C and A. So here also we can write vector B dot vector C plus vector B dot vector A is equal to 0. I'll call this as equation number 2. Next, in the same way, similarly, now vector C dot vector A plus vector B will be equal to 0. Therefore, vector C dot vector A plus vector C dot vector B is equal to 0. This I call it as equation number 3. Now, I add equation 1, equation 2 and equation 3. So for that, for adding, now look to the equation 1, 2 and 3. Now I am just adding the left hand side of all the equation. The left hand side of the equation 1 is this, and here for 2 it is this, and for 3 it is this. So I am adding the left hand side first. So vector A dot vector B plus vector A dot vector C. Then this is our first equation. Then plus vector B dot vector C plus vector B dot vector A plus next you have vector C dot vector A plus vector C dot vector B is equal to, now I am adding the right hand side of the three equations. So 0 plus 0 plus 0, it is 0. Now vector A dot B, vector B dot A, dot product, commutative. So vector B dot A can also be written as vector A dot B. So vector A dot B, vector A dot B will become what? 2 times vector A dot B. Next, vector B dot C and vector C dot B. Again, using dot product, this can be written as 2 times vector B dot C. Next, in the same way, vector A dot C, vector C dot A, this becomes vector C dot A is equal to 0. Okay, so if I take 2 common, I'll get 2 times vector A dot B, or let it be like this only. So this is the clue which we have got from the question. Now let us find what is magnitude of vector A plus vector B plus vector C. In order to find that, you already know now, we need to consider magnitude of vector A plus vector B plus vector C, the whole square, which can be written as vector A plus vector B plus vector C dot vector A plus vector B plus vector C. Okay, so this is equal to magnitude of vector A the whole square plus magnitude of vector B the whole square plus magnitude of vector C the whole square plus 2 times vector A dot B plus 2 times vector B dot C plus 2 times vector C dot A. Now substituting the values. So magnitude of vector A, they have given it as 3. So 3 square, it is 9. Magnitude of vector B is given it as 4. 4 square 60. Magnitude of vector C is 5. 5 square 25 plus. Now if you see, this entire thing is equal to 0 from your equation number 4. From 4, I can say 2 times vector A dot B plus 2 times vector B dot C plus 2 times vector C dot A is 0. Therefore, when you add this, we'll get it as 50. So, vector magnitude of vector A plus vector B plus vector C square is equal to 50. Hence, vector A plus vector B plus vector C is equal to root 50, which is nothing but 5 root 2. Understood? Next problem. Here they have given that I cap, j cap and k cap are mutually perpendicular unit vectors, and they have given 2 vectors alpha and beta. We need to express vector beta in the form of vector beta 1 plus beta 2. This is what we need to find. And here they have given that beta 1 is parallel to alpha and beta 2 is perpendicular to alpha. So let us pick up the first clue given. The given clue is beta 1 is parallel to alpha. So beta 1 is parallel to alpha means this implies that beta 1 is equal to lambda times vector alpha. Vector beta 1 is lambda times vector alpha. For collinear, we have seen. So vector A is lambda times vector B means the 2 vectors are collinear, or we can even say this parallel. So I am using this formula. So from this I can write vector beta 1 is equal to lambda times, what is vector alpha? 3 I cap minus of j cap. So this will be equal to 3 times lambda into I cap minus lambda into j cap. So from this, I got what is actually beta 1. So in order to express beta, vector beta in the form of vector beta 1 and vector beta 2, we need to find what is vector beta 1 and what is vector beta 2. So we found what is vector beta 1. So let us next find what is vector beta 2. So from the data, vector beta is nothing but vector beta 1 plus vector beta 2. From this, let us find what is vector beta 2. Vector beta 2 is nothing but vector beta minus vector beta 1. Okay, so this will be equal to vector beta we already know, which is equal to 2I cap plus j cap minus 3k cap minus vector beta 1, which is given by 3 lambda into I cap minus lambda into j. So simplifying, you will get 2 minus 3 lambda I cap, 2 minus 3 lambda into I cap. Next, 1 minus into minus plus, so it will be 1 plus lambda into j cap. Next you have minus 3 k cap. So when you subtract these two vectors, you get this. So anyhow we found what is beta 1 and beta 2, but still we need to find the lambda in order to find actually what is the value of beta 1, vector beta 1 and vector beta 2. So in order to find the value of lambda, let us use the second clue given in the question. The second clue given in the question that beta 2 is perpendicular to lambda. That given vector beta 2 is perpendicular to alpha. Okay, so it is understood that beta 2 dot vector alpha is equal to 0. The dot product between these two is 0. So vector beta 2 is given by 2 minus 3 lambda into I cap plus 1 plus lambda into j cap minus 3k cap. This is our vector beta 2 dot vector alpha, which is 3i minus j cap is equal to 0. Let us simplify this. So this into this, so you get 2 minus 3 lambda into 3. I dot I is 1. Next, 1 plus lambda into minus 1 plus 1 plus lambda into minus 1. Then minus 3 here, k component is not there, therefore it is 0. So this will be plus 0 is equal to 0. Let us simplify. This becomes 6 minus 9 lambda minus 1 minus lambda is equal to 0. 6 minus 1, it is 5. Minus 9 minus 1, it is minus 10 lambda. We need to find the value of lambda. Therefore, 5 by 10 is equal to lambda, means 1 by 2 is equal to lambda. We found the value of lambda. Now we substitute this lambda in beta 1 and beta 2. Therefore, beta 1, vector beta 1 will be equal to what? 3 times lambda. So 3 into 1 by 2 into I cap. Next, minus lambda j cap. So minus 1 by 2 into j cap. So the final thing you get it as 3 by 2 I cap minus 1 by 2 j cap. So next, what is your beta 2? Beta 2 is this one. So let us simplify that. Therefore, this will be equal to 2 minus 3 into 1 by 2 times I cap. Then we have plus 1 plus 1 by 2 into j cap. Then minus 3k cap. So this is equal to, so here this will be equal to 2 minus 3 by 2. So when we have 2 minus 3 by 2, LCM will be 2. Therefore you get 4 minus 3, which is equal to 1. Therefore we get 1 by 3 I cap, 1 plus 1 by 2, which is 3 by 2 j cap minus 3 k cap. Okay, so it is 1 by 3 I cap plus 3 by 2 j cap minus 3 k cap. Understood? So we got what is beta 1 and what is beta 2. We need to find what? We need to find beta. So here vector beta is vector beta 1 plus vector beta 2. So vector beta 1 is given by 3 by 2 I cap minus 1 by 2 j cap plus vector beta 2 Oh, sorry, here I have written it as 1 by 3, it is 1 by 2. Okay, so this is 1 by 2 I cap. Next we have plus 3 by 2 j cap. Then we have minus 3 k cap. So when I simplify 3 by 2 plus 1 by 2, it is 4 by 2. 4 by 2, it is 2 I cap. Next, minus 1 by 2 plus 3 by 2, it is 2 by 2, it is 1. Next we have minus 3 k cap. So if you see, we have expressed it, that means the answer which we have found is correct. So if you just find 3 here, beta 1 and beta 2, it will be enough. Next problem. They have given that vector A dot vector A is equal to 0 and vector A dot vector B is also equal to 0. They have asked what can you conclude about vector B. So they have given vector A dot vector A as 0. Okay, so this implies magnitude of vector A whole square is equal to 0. This implies that magnitude of vector A is what? 0. When I say magnitude of any vector is 0, then definitely the vector will be what kind of a vector? It will be a 0 vector. Therefore, I can say vector A is a 0 vector. Now, they are also given that is for any vector B, they have given that vector A dot B is equal to 0. Okay, so here from this I can say since vector A is a 0 vector, definitely the dot product between these two will be 0. So as vector A is a 0 vector, now we can say that vector B may be any vector. It need not be a 0 vector. It can be any vector. Even then, the dot product between A and B will be a 0 vector. Okay. Next, if either A is 0 or B is 0 vector, then A dot B is equal to 0. This is understood. Why? Because if any one vector is 0, then the dot product will be definitely equal to 0. Just now we have said. We have seen that vector A is 0, definitely the dot product is 0. But what they are asking, but whether the converse is true or not, we need to check by giving an example. That is, the dot product of the two vectors can be 0 if it is equal to 0. Then we need to show that the vector A is not a 0 vector and even vector B is not a 0 vector. This is what we need to prove. So for that, let us consider an example. I take vector A as vector I plus vector j and vector B as vector I minus of vector j. These are two vectors. So here we have where vector A and vector B are non-zero vectors. Okay. So we have considered two vectors which are non-zero. We are going against this. We are proving the converse. So let us find what is the dot product between these two. I cap plus j cap dot I cap minus j cap. So it is 1 into 1, it is 1 plus 1 minus 1 minus 1. But we got as what? We got the dot product between the two vectors are 0. So from this what we can conclude? Vector A and vector B necessarily did not it is not necessary for vector A and vector B to be a 0 vector in order to make the dot product between these two vectors as 0. So we can conclude that vector A and vector B are not necessarily what kind of vectors? 0 vectors. Okay, so even though by vector A and vector B are not a 0 vectors, but still we have the condition where the dot product between these two vectors will be 0. With this, we have completed the problems on scalar product.